Recording, and we'll go ahead and start the session with the last section for the test. I already have the test available for you guys. So again, to take the test, you need to go to the testing center. All right, we'll go ahead and start then. Today we're going to be talking about rational function. I've been doing a whole lot of experimenting on charts and stuff like that, and I noticed this is the best one that shows online. And I think it's a little bit big, huh? So hopefully that works better. Maybe next semester I'll be ready for that when they quit doing it. That'll be the best way to do it. Anyway, rational function is a function of the form of division of two polynomials. Consider two polynomials. We talked about polynomial last time. So we do have the division of two polynomials that is a rational expression. So these come in the form of an, say, x to the power m plus an minus 1 x to the n minus 1 plus whatever down to a0, and then say this is bm x to the power m plus bm minus 1 x to the power m minus 1 all the way to b0. The b's and n's are basically the exponents for the n, and m's are all both exponents, and an and bm are coefficients of the variables. Now remember, this n is again, and m would be the highest exponents on those polynomials. Yes, we're going to be using those in just a second. Okay, we said the domain of a rational function are all real number except the values of x that make the denominator and in this case it's q of x equals 0. So again, the condition is here, q of x not equal to 0. So anything you're dividing by, anytime you're dividing by a number, that number should not be 0. So if you divide by 0, you get undefined. Now, so these are basically the condition or the rules on these ones, these numbers. Now, what happens when the denominator gets to 0? If the denominator gets to 0 by any value of x, and the numerator is not 0, then we have what we call vertical asymptotes. Okay. Vertical asymptotes are basically vertical lines for which the graph will never cross them. Okay. So if I have a graph, say for instance, like this, and say I have a vertical asymptotes at this point, then the graph may get close to the line down here like this. I will never touch that line, will never cross that line. Or it may be coming from this side, okay? Depending on how the graph look like, it may be coming down this way or that. So one of those four conditions is gonna happen, but the graph is never gonna go like this. because it's crossing the point where it is not part of its domain. Remember, this asymptote is not part of the domain. That's why we have an asymptote. So therefore, the function will never have that x value. Okay? So with that, let's go ahead and take a look at simple graph and see how we graph rational function and what to look for. Before I go into that, let's go ahead again and take a look at, and let me write that. I'm just going to write the first term. The first term, again, we said this is the term with, on the numerator, where n is the term with the highest exponent. Okay? And then we said Pm, x to the power m, is the term on the denominator with the highest exponent. Okay? Now, we said vertical asymptotes happen when the denominator equals 0 and the numerator is not 0. For all those values in such situation will create a vertical asymptote. How about horizontal asymptotes? Now, these are the terms that we look at to determine if we have a horizontal asymptote. A horizontal asymptote is basically, say, a horizontal line, okay, at which the graph at the end of the line will never touch. Where? At the end of the line. However, in the middle of the line, it may do so. So your graph you can have like this. But as it is getting closer to the end, what happens? It continues along the line. Yes? And this way, the same thing. It may cross it in the middle, somewhere, doesn't matter. But at the end of the line, it will come along with it. It will never cross it. As the value of x gets bigger and bigger and bigger. Okay? However, in the middle, it is possible. It may cross it several times, it really doesn't matter. The graph may go like this. And then at the end, we still do go along with it. Yes? So let's go ahead and take a look at how do we determine the vertical asymptote. Three conditions. We look at the exponent, n and m. So those three exponents have three conditions. Either n and m are the same, or one is bigger than the other. So n could be bigger than m, or m could be bigger than n, right? Let's take a look at all three conditions. If n is greater than m, so that means the value over here is greater than that, yes? Then we say no horizontal asymptote. Yes? We may, however, have a different kind of asymptote, and that is that's called oblique asymptote, but we'll talk about that when we get to it. If condition number 2, n and m are the same. So another way, let's say you have x squared on top, x squared on the bottom. The horizontal asymptote y equal the coefficient of those exponents. That will be an over Bm. Wherever the coefficient of those exponents are, would be your horizontal asymptote. So for example, if An is 2, and say Bm is, let's say, 3, yes? Then you will look at the point 2/3, which is over here, say, and this is where your horizontal asymptote is. Yeah? Clear? If n is less than m, another way, let's say we have x on top, we have x squared on the bottom, or x cubed, or what have you, yes? As long as the denominator has a bigger value than the numerator, then y equals 0 is horizontal asymptote. So those are the three conditions for your horizontal asymptote on the graph. Okay? So now we know how to determine the vertical asymptotes by just taking the denominator, setting it equal to 0, and making sure that every value we get does not make the numerator 0. So therefore, that's the asymptote. And for the vertical asymptote, just take a look at the graph, at the equation or the function, and compare the exponent. Yes, and based on that, you can determine what the horizontal asymptote is going to be like. Okay, so let's take a look at some graph. Let me go ahead and erase this. Say for instance, you want to graph the function f of x equals 2 over 1 plus x. Say graph the function f of x equal 2 over 1 plus x. So the first step in graphing the function is determining what the asymptotes are. Do I have any asymptotes? Yes? Okay, let's determine the vertical asymptote. For vertical asymptote, we're going to take the denominator, say 1 plus x, we're going to set that equal to 0. Yeah? And we're going to solve the equation for x. So we're going to move x to this side, or 1 to this side. So x equal -1. When x equal -1, I'm going to look at the numerator. Notice the numerator is just a value. It's never going to be 0, correct? So all the values I get from setting the denominator equal to 0 will be asymptotes. Okay? So now let's go ahead and take a look at starting the points on graphing these things. Okay? So first asymptote is for x equal -1. So I'm going to go to x equal -1, say over here, and just make a dotted line in there and say the graph is not going to get across this line. So another way, when I come to graph this equation, I'm going to have two portions. One portion is going to be on this side, and one portion is going to be on this side. Okay? Let's see what happens. Next, let's determine the horizontal asymptote. Let's determine the horizontal asymptote. Again, we said in order to determine the horizontal asymptote, we're going to look at the highest exponent for x on top and the highest exponents for x on the bottom. Yes? Now, the top number does not have an x. That means the exponent of x is 0. Yes? Because x to the power 0 equal to 1. And this is the same thing as x to the 0, right? So providing x is not 0. So in this case, so the top exponent, let's say it's 0. The bottom exponent is 1. Yes? The bottom exponent is 1. Based on the rule we just set, if the top exponent is smaller than the bottom exponent, then we know y equals 0 is a horizontal asymptote. Yes? So now we're going to take a line on the graph, the y equals 0. This line is just simply the x-axis. Yes? This is my asymptote, right? So now, we said on this asymptote, the graph is going to come either this way, this way, this way. Now, I don't know which way. Not yet. Yes? And on this one, at the end, it's going to be like this again. Those are the endpoints. Okay? So to determine these, we need to just simply take some points and determine the value of the graph or the function at that particular point. So let's say, for example, x equals 0. Yes? If x equals 0, let's make a table right here and start with x equals 0. When x is 0, then we have f of x is 2 over 1, which is simply 2. Yes? So I'm going to go to the value 0. And then let's say 1, 2. So that point is going to be on the graph. Okay? Let's take, for example, anybody have a calculator on them? Let's take x equals -2. If x is equal to -2, yeah, then 2 divided by 1 minus 2, right? 1 minus 2 is -1. 2 divided by -1 is -2. So the y value is -2 right here. Yes? Now you can see right away that this portion of the graph looks the one is going to be, right? So, because this point is in this area over here. Yes? Now, let's see what happened. Let's see what happened when x gets very close to -1. Okay? So we can get it close to -1 from this side, right? Or from this. If I come from this side, I'm just going to use, let's say, negative. Let me put the 0 2 on the other side. Say 0, 2. Let's say negative 0.99999. This is my negative. Okay? What value do I get if I plug this in there? Let's see. That's 1, 2, 3, 4, 5. Yes? So that's going to be 2 divided by negative. 2 divided by 0.00001. Yes? That's going to be 200,000. Yes? That's going to be what? 200,000. Without your calculator, you can do that. Now, the closer you are to this side, the bigger the number is going to be. So that means on this side of the line, to the right side of the line, the graph is coming this way. And it's getting smaller as it goes. Yes? Now, what happened on the other side? So let's go ahead and say, I should have put the negative 1 on this side. Let's say now we're going to use on this side, let's say negative 1.00001. Okay? What's going to happen? When I say 1 plus a negative number, notice this number is a little bit bigger than 1, correct? So what do I get here? I'm going to get a negative number. It's a very tiny number, but it's going to be simply negative, yes? So when I divide 2 by the same number except in the negative, now I'm going to get negative 200,000. So when I am on this side of the line, the graph is coming from this area, correct? And of course, we need to check whether it's going to cross the line or not. This case is not going to cross the line. When we get to that, we'll talk about this. Yes? So this is basically how we graph this particular function. Yes? Any questions? I don't think the book talks about points where it does cross the vertical axis. So we're not going to worry about that. But if you do want to determine if this is going to cross the line or not, you take the function, say, 2 over 1 plus x, and you set it equal to the asymptote, whatever the asymptote is. Yes? And you set it equal to 0. If this function or this equation has a solution, then whatever that solution is, this is where it crosses the x-axis. Yes? If it doesn't have a solution, that means it doesn't cross it either. Yes? This particular equation does not have a solution because this fraction will never be what? 0. So therefore, we know the graph is not going to cross this line at all whatsoever. Clear? Let's take a look at another example. Say, for instance, we're looking at f of x equal, say, 2x squared over x squared minus okay. So now we need to determine, do I have any vertical asymptotes? So I'm just going to take the denominator. Let's solve for vertical asymptote. I'm going to take the denominator. We're going to make that equal to 0. Okay? And then we're going to solve the equation. So we have x squared minus 4 equals 0. Okay? This is a binomial, so in this case I can leave the x squared on one side, equal 4. Okay? So when I square x and I get 4, what would the value of x could be? Only 2? Minus 2. And minus 2. Notice when you take the square root on one side, you always say plus or minus. So that's equal plus or minus square root of 4, which is plus or minus 2. So that means this particular graph may have two asymptotes. Yes? The first asymptote would be plus 2. The second asymptote would be minus 2. But we need to check, are they both asymptotes? How do I check them if they are asymptotes or not? I'm going to plug in 2 in the numerator. If that gives me a 0, then it's not. If it doesn't give me a 0, then it is. If I put a 2 in here, do I get a 0? 2 squared is 4. 4 times 2 is 8. So I don't get a 0. So x equal to, first of all, it is a vertical asymptote. That's for sure. How about minus 2? If I plug in minus 2 here, what do I get? X squared, so minus 2 squared is 4. 4 times 2 is also 8. I don't get a 0, so that means the other asymptote is x equal minus 2. So now this graph has two asymptotes. Okay? What are these two asymptotes? -2 and 2. And those are going to give me so notice we've divided the graph into how many sections? One on this side, right? One in between, correct? And then one outside. So we should maybe expect a 3 region for the graph. Again, let's go ahead and take a look at the horizontal asymptote. Okay? How do I determine the horizontal asymptote? We said we will take a look at the highest exponents on top and bottom, right? Okay. In this case, they are exactly the same, yes? So the asymptote would be whatever in front of the first term, right? Divided by whatever in front of this term. What do I have in front of this term? 1. Yes? So then, y equal, the top number is 2, the bottom number is 1. So that's equal to, clear? Now, if I go to the y value 2, I can make nothing. Yes? Any questions? Is the graph going to cross this line? Is the graph going to cross this line? I just said we were going to look at it. Let's look at it. Yes? To look at it, we said we take the equation, we set it equal to 2, right? Let's take a look at that and see what happens. So I'm going to take 2x squared divided by x squared minus 4, and I'm going to say if this is equal to 2, what would the value of x be? Or is this ever going to be equal to 2? Now here's a question mark. Is this ever true? Let's see. To solve this, we cross multiply. Yes? So we end up with 2x squared equal 2x squared minus 8. We're going to bring all the x's, or we're going to bring everything to one side. Okay? So what do I end up with? 2x squared, bring this over here, minus 2x squared plus 8 equals 0. Correct? What happened to those two terms? It cancels. What do I have left? 8 equal to what? Is that possible? No, so this is not possible. So the graph is not going to cross this line either. Okay? This is how you determine whether is it going to cross the horizontal line or not. Definitely, we said on the vertical line, it will never cross. But now we guarantee also it's not going to cross this line. Yeah. Possibility for the graph. On this line, it can come like this or like that. On this line, it can come like this or like that. Here like this. Here like this. Like this. Like this. By taking a couple of points, you will know what happened. Okay? So let's take a point on this side. We said this is how much? -2. And this is 2. Correct? So let's see what happens if I take a number on this side of -2. Let's say, for instance, -3. So if I substitute -3 into the equation, 2 times -3 squared divided by -3 squared minus 4. This point over here is 2. Let's keep that in mind. Okay? So that is equal. -3 squared, that is 9. Correct? 9 times 2 is 18. On this bottom one, we have -3 squared is 9. Yes? And 9 minus 4 is 5. So far, so good. Okay. Where is that point at? If I'm here, -3, am I going to be above there or somewhere below this line? Let's take a look. 18, if I divide 18 by 5, what do I get roughly? 3 point something, right? So that's higher than 2. So this is going to give me a point there. Correct? So I know for sure now the graph is going to look a little bit like this over here. To be more accurate, just use more points. Okay? Let's see what happened between -2 and let's see what happened on this side. On this side, it could come like this. It could come like this. It could have a whole lot of issues, right? However, we did say it will never cross this line, right? So if it was on top, it stays on top like that. If it was on bottom, it's going to stay on the bottom like that. Okay? So let's see what happens. But if it does cross the line, it may cross it in this area. Then you could come from top, bottom, whatever point it's going to cross the line. But we already determined it's not going to cross the line. So I don't have to take too many points. I can take 1 point. Let's pick a point. Say 0. Okay? If I choose a 0 for x, on top we end up with 0. 0 divided by a number is going to give me what? A 0? Yes? So this point is on the graph. Okay? We already said the graph is not going to cross this. So the graph is going to go up, come to the 0, and go down. Or maybe come somewhere along the 0. You can figure out how high it's going to go up there. Yes? We can figure out how high is that going to go up there. Now, let's see what happened to the graph on this side. Let's see what happened to this graph on this side. On this side, I'm just going to take a number bigger than 3. Okay? Let's put a number, bigger than 2. Well, let's put a 3 in there. is this value going to change? I'm going to make that 3, correct? I'm going to make that 3. And what up? 3 squared is still 9. 9 divided by times 2 is 18. And then we have 9 minus 4 is 5. And the graph is somewhere in here. So that is basically, it doesn't matter how hard it looks, the function. Most of the stuff in there is just basically knowing when it is going to be 0. So those will go back into factoring equations. Okay? If you know how to factor equation and solve it, graphing this should be very easy for you. Okay? Let's see. Let's see if I can pick up a function. Okay, let's take a look at this one. One more. X minus 3 x squared plus x minus 2. X squared plus x minus 2. Okay? And let's see if we can determine what all of this, what's going on with this particular graph. Okay? All right, let's see. So we're going to say, first, we're going to determine the vertical asymptote. Yeah? And that vertical asymptote is, we're going to take the denominator, say x squared plus x minus 2. We're going to set that equal to 0. This is a quadratic function or quadratic equation. To solve it, we need to do factoring first. Okay? Or use the quadratic equation. This looks like it might be easy to factor. So we're looking for two numbers. When I multiply them, I get a negative 2. And when I add them, I get the number in front of x, which is 1. Okay? So what two numbers you multiply, you get negative 2. The only two numbers are 1 and negative 2, or negative 1 and 2. Anything else? Now, which one of these, when you add them, you get 1? Top one or the bottom? The bottom, yes? So now we know what the numbers are. So negative 1 and 2. So we're going to say this is equal to x minus 1, x plus 2 equals 0. Correct? So now we can say x must be, if x minus 1 equals 0, then x is equal to 1. And if x plus 2 equals 0, then x is equal to minus 2. So far, so good. So now we're going to go to minus 2. as 1. We haven't decided they are, but I know they are. Let me just go ahead and write them. Of course, we needed to check those first before we put them in there. If x is 1, 1 minus 3 will give me a -2. That's not 0, right? So it is an asymptote. And if x is -2, -2 minus 3 is -5. It's not 0. So therefore, the second one is also an asymptote. Okay? Let's determine the horizontal asymptote. What is the horizontal asymptote? Again, the horizontal asymptote, we said we take a look at the highest exponent on top, the highest exponent on the bottom. The top is 1. The bottom is 2. Top is smaller than the bottom. So that means y equals 0 for the horizontal asymptote. So now we're going to have this graph like that. Okay, now let's see. Is the function going to cross this line? Is the function going to cross this line? How do I determine that? We said we take this, we set it equal to 0, and we see how it works. Let's see, we have x minus 3 divided by x squared plus x minus 2 equals 0. Okay? So notice this one is x minus 1, x plus 2. Correct? We cannot simplify by any of these. Yes? Now we see that this is equal 0 when the numerator equal to 0. Yes? And then x minus 3 equals 0, then x equal to 3. Is the 3 an acceptable value? Let's see. I put it in the denominator. Does it give me a 0? 9 plus 3 is 12. 12 minus 2 is 10. It's not a 0, so this, therefore, the graph will cross the asymptote at x equal to 3. So that means at 1, 2, 3, this point is part of the graph. So note, the graph may come down here, but what it's going to do after that? It's going to have to go up and go around. Clear? Or it may go like this, and it's going to cross this point, but it's going to do like this. Clear? All right, now let's see what happens. Now we know the graph is going to cross this asymptote at that point. So now let's go ahead and graph this equation. To graph it first, we need to take a point on this side. We need to take a point on this side. We need to take a point on this side, at least. So taking a point on this side, this is -2, let's say -3. So -3 minus 3 divided by -3 squared minus 3 minus 2. That's going to give me -6. What do I get here? -3 squared is 9. 9 minus 5 is 4. That's going to be -3 over 2. That's going to be -1.5. So it's about this side over here. That's really what I'm interested in. We know it doesn't cross this line in this area, does it? This is my other asymptote. So the graph on this side go like this. Okay? So let's take a point over here in the middle. Let's say x equal the easiest one will be 0. Okay? When x is 0, we end up with negative 3 over negative 2, which is 3 over 2. So it is going to be above the line. Let's say over here. Okay? But we just said the graph doesn't cross this line in here, does it? So that means in the middle, graph goes like that. Okay. What happened on this side? Let's take a point, say 2. Because we know it crosses the graph at which point? At 3. I just want to know, does it come from top or bottom? Yes? So I'm going to take a 2. I'm going to substitute. So we end up with 2 minus 3 divided by 2 squared plus 2 minus 2. And that's going to give me negative 1 over 6 minus 2 is 4. So negative 1 over 4 it is. Right here. So the graph is going to go like that. And it's going to cross a 3. And it's going to go down. Yeah. Now how far does it go up or down? That's not our lecture today. Yeah. Any questions? Okay, that's all about graphing for rational